Oceanography News.
So water roll me home. Day will come, but night is long. The siren song still calls me young. The fading candle is growing dim. So
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.
A trend in marine and oceanography news lately has been marine heat waves, including this story. Sea temperature in Portugal's Algarve reaches record highs as marine heat wave hits. Temperatures in the Algarve between June and July were on average 25.1 degrees Celsius, according to Portuguese Maritime Authority. Portugal's southern Algarve region experienced a marine heat wave, the country's maritime authority said on Tuesday, after collating the results recorded by a buoy placed in the sea near Faroes beaches between June 28th and July 9th. The buoy is part of a Hydrographic Institute national monitoring network. According to the data, the waters around the beaches in the area reached temperatures of up to 25.1 degrees Celsius. In a story July 11th, Med Sea heat wave might feel nice for holiday swimming, but there's a catch. The temperature of the sea surface regularly passed 30 degrees C off the coast of Majorca and elsewhere in late June and early July, in places 6 or 7 degrees above usual. That's probably warmer than your local swimming pool. It's been the Western Med's most extreme marine heat wave ever recorded for the time of year, affecting large areas of the sea for weeks on end. Heat appears to be cooling off, but some species struggle to cope with such prolonged and intense warmth, with potential knock-on events for fish stocks. To give some idea of these temperatures, most leisure swimming pools are heated to roughly 28 C. Competitive swimming pools are slightly cooler at 25, World Aquatic says. Balmy temperatures can pose hidden threats. Harmful bacteria and algae often spread more easily in warmer seawater, which isn't treated with cleaning chemicals like your local pool. As you can see from the graphs and the data, there's been some pretty high temperatures recorded in the Mediterranean recently, and definitely more study and more CTDs should be used to look into the matter. Sea temperatures of 30 C or above are not unprecedented in the Med in late summer, but they are highly unusual for June, according to data from European Copernicus Climate Service, Mercator Ocean International, and measurements at Spanish ports. What is different this year is that 30 C sea temperatures have arrived much earlier, and that means we can expect the summer to be more intense and longer, said Marta Marcos, associate professor at the University of the Balearic Islands in Spain. I grew up here, so we're used to heat waves, but this has become more and more common and intense. We're all very, very surprised at the magnitude of this heat wave, added Ada Alva Ascarate, an oceanographer at the University of Liège in Belgium. It's a matter of high concern, but this is something we can expect to be happening again in the future. Marine heat waves are becoming more intense and longer lasting as humanity continues to release planet-warming gases into our atmosphere, principally by burning coal, oil, and gas. In fact, the number of days of extreme sea surface heat globally has tripled over the past 80 years, according to research published earlier this year. Global warming is the main driver of marine heat waves. It's essentially transferring heat from the atmosphere to the ocean. It's very simple, said Dr. Marcos. The Mediterranean is particularly vulnerable because it's built like a bathtub, largely surrounded by continents rather than open ocean. That means water cannot escape easily, so its surface heats up quickly in the presence of warm air, sunny skies, and light winds, as happened in June. The heat peaked as June turned to July, after which stronger winds allowed deeper, cooler waters to mix with the warm surface above and bring temperature down. The temperatures remain above average, and there could be consequences for marine life that we don't yet know about. Most life has temperature threshold beyond which it can't survive, though it varies a lot between species and individuals. But sea creatures can also suffer from prolonged heat exposure, which essentially drains their energy through the summer to a point where they can no longer cope. I remember 4 years ago diving in September at the end of summer, we found skeletons of many populations, said Emma Cibrian, an ecologist center for advanced studies of Blanes in Spain. Seaweeds and seagrasses act a bit like the forests of the Mediterranean Sea, home to hundreds of species, as well as locking up planet-warming carbon dioxide. Some of them are well adapted to typical Mediterranean warm temperatures, but actually they cannot withstand marine heatwave conditions, which are becoming more extreme and widespread, said Dr. Sebrian. Marine heat waves can also increase evaporation, adding moisture to the atmosphere, which can cause extreme rainfall. This happened in Libya in 2003, and as you can see here, in Valencia in 2024. And warmer waters can reduce the cooling effect that coastal populations would usually get from the sea breeze. That can make things very uncomfortable if there's another heat wave later in the summer, Dr. Marcos warned. I'm pretty sure that's going to be horrible. The ocean is extremely important to our survival as a human race. The next story is from JFK, who, like us, didn't get it right the first time, but hopefully, with enough effort, did get the message correctly.
The seas around us represent one of our most valuable resources. If vigorously developed, this resource can be of great benefit to our nation and to all mankind. But it will require concerted action, purposely directed, with vision and ingenuity. It will require the combined efforts of our scientific... All right, I'll start again. The seas around us represent one of our most important resources. If vigorously developed, this resource can be a source... We don't want to say this resource can be a source. The seas around us represent one of our most important resources. If vigorously developed, this resource can be of great benefit to the nation and to all mankind.
It's funny, but what he really meant to say was...
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it. The seas offer a wealth of food for the people of the world. Mineral resources on land will ultimately reach their limits. We may be able to extract additional elements in the water. To predict, and perhaps someday to control, changes in weather and climate is of the utmost importance to man everywhere. These changes are controlled to a large and yet unknown extent by what happens in the ocean. Additional research is necessary to identify the factors in this interplay. These are some of the reasons which compel us to embark upon an important national effort in oceanography. This is not a one-year program or even a 10-year program. It is the first step in a continuing effort to acquire and apply the information about a part of our world that will ultimately determine conditions of life in the rest of the world. The opportunities are there. A vigorous program will capture those opportunities.
Warming ocean is causing problems for some animals and the fisheries. Warming ocean is big turnoff for critically endangered angel shark. Warming ocean temperatures are becoming a major turnoff for female critically endangered angel sharks that are now prioritizing staying cool over visiting crucial breeding grounds when things get too hot. A new study from University of Lancaster has concluded. The changes observed are creating potential mismatch in mating behaviors between the sexes of angel shark. The focus of the study that could, experts have warned, have severe consequences for the future of the species. Led by researchers at the university, the team of scientists comprising experts from the Angel Shark Project, Canary Island and Zoological Society of London used acoustic trackers to discover the prolonged warming of seas around the Canary Islands is disrupting the reproductive behaviors of female angel sharks. During a period of unusual and extreme high sea temps in 2022, researchers found female angel sharks were absent from the species' traditional mating grounds within the La Grotte Marine Reserve, located off the coast of Lanzarote and recognized as the largest marine reserve in Spain. That year, sea surface temps in the study rose to more than 23.8 degrees Celsius and remained above 22.5 degrees C, nearly 3 times longer than in previous years. Crucially, these very high temps persisted throughout the entire angel shark mating season, which traditionally starts in late autumn when seas should be cooler. While female angel sharks appeared to be put off by warmer seas, however, the males were not deterred and returned to sites in November as normal in search of mating opportunities. Dr. David Jacoby, a lecturer in zoology at Lancaster University and principal investigator of the study, said, "These more frequent and extreme heat waves are potentially the wildfires of the ocean and are having untold effects on marine species. With angel sharks, we observed important sex differences in behavior, with females being disproportionately influenced by sea temperature rises, causing them to be absent from their traditional mating sites during this extended period of warming. The males were much more resilient to temperature rises and stuck to their regular patterns of arrival and departure, seemingly prioritizing mating despite these temperature extremes." Studies showed that female angel shark presence is strongly linked to temperature, and that 22.5 degrees Celsius may be an approximate upper thermal limit for females. Scientists believe the reason female angel sharks are prioritizing staying cool over mating is likely due to their biology. Female angel sharks have more energetically demanding lifestyles because of reproductive biology, and as a result, are more sensitive to temperature. Eva Myers, co-lead of the Angel Shark Project, states, "These findings are a reminder of how climate extremes are already reshaping the behavior of threatened marine species. The study highlights exactly why long-term monitoring of critical habitats in the Canary Islands must be a key pillar of any effective marine biodiversity recovery plan. The Canary Islands are one of the main strongholds for the species. Safeguarding these waters is more urgent than ever." Not just the angel sharks, how marine heat waves are reshaping entire ocean ecosystems. Research from University of Victoria has gone to new lengths to highlight how marine heat waves can not only dramatically impact marine ecosystems but reshape ocean life as we know it, by offering a stark preview in the future of ocean warming. From 2014 to 2016, the Pacific coast of North America experienced the longest marine heat wave ever recorded, with temperatures rising 2 to 6 degrees above historical averages over a prolonged period of time. It's according to researchers from University of Victoria's Baum Lab that this marine heat wave alone resulted in unprecedented ecological disturbance of some thousands of kilometers of North American west coast. By reviewing the findings from the 331 primary studies and governmental reports, the researchers believe they are now gaining a better understanding of how ecological impacts of marine heat waves, including its effect on marine life. According to the study, 240 different species were found outside of their typical geographic range during the heat wave, with many of them found further north than ever before. Several species, such as the northern right whale dolphin and the sea slug Placida cremoniana, were found over 1,000 kilometers north of their typical habitat. The heat wave caused widespread kelp and seagrass decline, and many kelp forests collapsed. Species from sea stars to seabirds died on unprecedented scales, and unusual mortality events were observed in several species of marine mammal. Meanwhile, a rocky shore predator, Pycnopodia helanthoides, came close to extinction. Researchers found that many of the impacts of the heat wave were cascading, with direct impacts on some species driving complex dynamics that affected everything from plankton to whales. Temperature-linked diseases such as sea star wasting disease also contributed to the ecosystem collapse, while the reduced abundance and nutritional quality of forage fish caused issues for predators. Meanwhile, plankton communities reorganized and offshore oceanographic productivity was found to be altered. Heatwave also came with weighty economic costs and saw the closure of multiple fisheries driven by changes in species interactions, disease proliferations, and habitat loss, deliver financial losses in the hundreds of millions of dollars. The study underscores the urgent need for proactive ecosystem-based marine conservation strategies and climate change mitigation measures. According to the paper now published in the scientific journal Oceanography and Marine Biology in Annual Review, the 2014 to 2016 marine heatwave in the Northeast Pacific, despite its exceptional duration and geographic scope, shares many ecological impacts with other marine heatwaves observed around the world. Other than using our D2 CTDs, another way oceanographers are studying these marine heatwaves is with divers. Scuba divers are the heart of the Blue Dot Project. By uploading the profiles from their dive computers onto divelogs portals and consenting to share these to the Blue Dot scientific database, divers make a valuable contribution to marine research. The project team uses the citizen-sourced data in compliance with data protection regulations to monitor and record temperature changes across different parts of the Mediterranean Sea and from coastal regions worldwide. The team has already evaluated diving data from the Med. As Galern expected, these indicate that average ocean temperatures are rising steadily. The water masses of the ocean act as heat reservoirs that interact with the atmosphere and thus influence the climate. If this system becomes unstable with the continued warming of surface water, it could lead to the intensified evaporation and ultimately regionally limited extreme precipitation events in the surrounding areas. The constant warming and increasing frequency of marine heat waves also have significant implications for biodiversity and ecosystem services our oceans provide, making these phenomena a critical factor considered in both research and management. There presently exists what is known as sampling bias in the data. This is exhibited by a clear predominance of data obtained during the warmer months and the holiday seasons. In order to be able to establish an average value, we'd like to encourage divers to enter their data, including their older data, into our portal and also to record and upload data from the cooler seasons, says Galern. By filling these seasonal gaps, divers can play a crucial role in building a more complete and accurate picture of how ocean temperatures are changing throughout the year. CSA Ocean Science's extraordinary marine discovery at the Leviathan production platform in the Mediterranean Sea. During an annual environmental monitoring survey of the water surrounding the Leviathan production platform, an offshore natural gas platform located in the Mediterranean Sea, an unexpected phenomenon was observed. Numerous colonies of the soft coral species Dendronpithia hemprichi, native to the coral reefs of the Red Sea, were discovered growing on the platform's subsea structures at depths up to 30 meters. Following this exciting finding, renowned marine biologist Dr. Tom Schlesinger from the School of Zoology and Steinhardt Museum of Natural History and Professor Yehuda Benayahu from the School of Zoology initiated a collaborative research program to further investigate this discovery. The research will be led by a master's student under the guidance of the researchers in partnership with Chevron Mediterranean Limited, operator of the Leviathan production platform, on platform team and operational vessel, as well as project partners New Med Energy and Ratio Energies. The ongoing study will include periodic underwater visual surveys and collection of coral samples for an in-depth study of their reproductive biology and their dispersal capabilities in the Mediterranean Sea. The Leviathan Partnership remains committed to operating responsibly, transparently, in collaboration with the academic and scientific community in Israel. CSA is proud to have continually provided environmental monitoring services around the Leviathan production platform for the past 5 years. Next story is from Hui, Woods Hole Oceanographic Institution. If the ocean had a yearbook, the basking shark would definitely be named Most Chill. This massive shark gets its relaxed reputation from the way it seems to bask in warm surface waters in almost every ocean around the world. Their eating style is called ram feeding, but in reality it's pretty passive. Swimming slowly through dense patches of zooplankton, the shark filters the water through gill rakers encircling its head. From Diodon Drone Technology, UAV/USV interoperability, showcasing our expertise in experiment led by NATO Allied Command Transformation Act. Building on multiple successful real-world trials, they were selected by NATO ACT to join the Task Force X Baltic initiative to integrate autonomous systems into joint naval operations. Our mission: operate UAVs in a demanding operational context by designing a deployment module from USVs and ensuring full interoperability with naval platforms and command chain. And as you can see from this following video, they have accomplished this and much more. Scientists solve 75-year-old mystery of massive gravity hole in the Indian Ocean. Seen from space, Earth looks smooth and round, but this view hides a bumpy truth. Beneath the surface, mass is not spread evenly. The unevenness alters gravity across the planet, warping its shape. Tectonic plates add to the drama, pushing mountains upward and opening deep valleys. These shifting forces change Earth's form over time. Even the oceans reflect this hidden turmoil, covering over 70% of the surface. The sea might seem level, but it's not. If you removed all the tides and currents, seawater would settle into an undulating surface shaped by gravity, known as the geoid. The invisible contour dips where gravity is weak and bulges where it's strong. These dips and bulges, called geoid anomalies, reveal how Earth's mass is arranged deep below. One of the most extreme of these anomalies is the Indian Ocean Geoid Low, IOGL, discovered in 1948 by Dutch geophysicist Felix Andries Venning, Maynez. It stretches across 1.2 million square miles, hence the ocean surface sinks 106 meters lower than nearby areas. For decades, this massive gravitational dip puzzled scientists and remained one of Earth's greatest unsolved mysteries. According to Professor Atri Ghosh, a geophysicist at the Center for Earth Sciences, Indian Institute of Science, the existence of the Indian Ocean Geoid Low is one of the most outstanding problems in Earth sciences. She emphasized it's the lowest geoid gravity anomaly on Earth, and so far no consensus existed regarding its source. To find a potential answer, Ghosh and her colleagues used computer models to set the clock back 140 million years in order to see the big picture. Geologically, we have some information and some confidence about what Earth looked like back then, she said. The continents and the oceans were in very different places, and the density structure was also very different. From that starting point, the team ran 19 simulations up to present day, recreating the shifting tectonic plates and the behavior of magma inside the mantle. In 6 scenarios, a geoid low similar to the one in the Indian Ocean formed. The distinguishing factor in all 6 models was the presence of plumes of magma around the geoid low, believed to be responsible for the formation of the gravity hole. The plumes themselves originated from the disappearance of an ancient ocean as India's landmass drifted and eventually collided with Asia tens of millions of years ago. India was in a very different place 140 million years ago. There was an ocean between the Indian plate and Asia. India started moving north, and as it did, the ocean disappeared and the gap with Asia closed, Ghosh explained. As the oceanic plate went down inside the mantle, it could have spurred the formation of the plumes, bringing low-density material closer to Earth's surface. A geoid low, or negative geoid anomaly, could be caused by mass deficit within a deep mantle. Our study explains how this low, with hotter, lighter material, stretching from a depth of 300 kilometers up to 900 kilometers in the northern Indian Ocean, most likely stemming from the African superplume, says Professor Go. The geoid low formed around 20 million years ago, according to the team's calculation. It's hard to say whether it will ever disappear or shift away. That all depends on how these mass anomalies in the Earth move around, Ghosh said. It could be that it persists for a very long time, but it could also be that the plate movements will act in such a way to make it disappear a few hundreds of millions of years in the future. Dr. Alessandro Forte, professor of geology at the University of Florida, believes there is good reason to carry out computer simulations to determine the origin of the Indian Ocean geoid low. However, Forte identified a couple of flaws in the study's execution. Earth beneath your feet is far from still. While we understand quite a bit about the Earth's surface, the interior remains a mystery. Image credit International Center for Globe Earth Models. The most outstanding problem with the modeling strategy adopted by the authors is that it completely fails to reproduce the powerful mantle dynamic plume that erupted 65 million years ago under the present day location of Reunion Island, he said. The eruption of lava flows that covered half of the Indian subcontinent at this time, producing the celebrated Deccan Traps, one of the largest volcanic features on Earth, have long been attributed to a powerful mantle plume that is completely absent from the model simulation. Another issue Forte added is the difference between geoid or surface shape predicted by the computer simulation and the actual one. These differences are especially noticeable in the Pacific Ocean, Africa, and Eurasia. The authors mention that there is a moderate correlation around 80% between the predicted and observed geoids, but they don't provide a more precise measure of how well they match numerically in the study. This mismatch suggests there may be some deficiencies in the computer simulation. Roche acknowledged that not every possible factor can be accounted for in these simulations. That's because we do not know with absolute precision what the Earth looked like in the past. The farther back in time you go, the less confidence there is in the models. We cannot take into account each and every possible scenario, and we also have to accept the fact that there may be some discrepancies in how the plates moved over time, she said. We believe the overall reason for this low is quite clear. The study is a significant step in the understanding the IOGL, providing a credible explanation of one of Earth's most intriguing gravitational anomalies. Future research will continue to refine these models and explore the complex dynamics of Earth's interior. Please make sure to subscribe and like and share this video, and head over to d-2.com/news and bookmark our news page and check it regularly so you don't miss out on important updates like my recent interview with Marine Technology News. Thanks again for watching, and hope you have a wonderful day.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.